now we'll see what is the effect of feedback on bandwidth of the system. Basically, what is bandwidth? So bandwidth is a range of frequencies for which the system allows those signals. So generally low pass filters, control systems are low pass filters, therefore the bandwidth we can define for such system is the frequency at which the gain of the system reduces from maximum value to 1 by root 2 times of its maximum value. So that is what the bandwidth is. Let us look at what is the bandwidth for my non-feedback system and also the feedback system, and how can we compare those two. Let us take the open loop transfer function, which is a non-feedback system. So the transfer function which we have taken g of s is k by 1 plus st naught. This is my open loop transfer function or non-feedback transfer function. Then find the magnitude of it. To find the magnitude we need to substitute s is equal j omega. So let us substitute s is equal j omega, get the sinusoidal transfer function, which is g of j omega is k by 1 plus j omega t naught. Then what is the magnitude? So the magnitude is going to be, numerator is k, denominator is 1 plus whenever you have j, then we need to get a square plus b square under root. So which means here 1 plus omega t naught whole square. Now this particular magnitude is equal to the magnitude of the system, the maximum magnitude of system, and that to be 1 by root 2 of times of it. That means we know the gain of the system is k, the magnitude is gain by root 2. So now what I need to do is, wherever omega is there, substitute omega b and take the magnitude and equate it to k by root 2. Now, so we do that. So I am just replacing this equation wherever omega is there with omega b, and which is equal to k by root 2. Then we will get one equation here like this, and we can find the solution of it. Then we can derive this that omega value, which is omega b, as 1 by t naught. That means for non-feedback system, for open loop system, the bandwidth frequency is going to be 1 by t naught, or 1 by time constant of my open loop system. Similarly, let us take the closed loop transfer function or the feedback system transfer function. The same g is k by 1 plus st naught, then we can find out g by 1 plus gh, assume h is equal to 1. And we will be getting the transfer function as k by 1 plus k divided by, we have 1 plus s into, we have 1 plus k by t naught by 1 plus k. Right, so get the magnitude. Before that, substitute s is equal j omega. So then I am writing the magnitude like this, and when omega is omega b, then that is equal to, my gain should be 1 by root 2 times. Therefore gain is 1 by 1 plus k and whole divided by root 2. Then again, if you equate these two, then we will be resulting like this. Your omega b is going to be 1 plus k by t naught. So for non-feedback system, omega b is 1 by t naught. For feedback system, omega b is 1 plus k by t naught. Then what is the conclusion here? So the closed loop system bandwidth is increased by the factor 1 plus k. Then what is the effect of this bandwidth? If you have more bandwidth, which means we are trying to allow more frequency signals into my system. That means my system will respond very fastly. It will also respond for the fastly changing signals. Therefore, my rise time of the system decreases, which indicates the speed of the system increases. Now, so the next is the effect of feedback on sensitivity of the system. As we know, the sensitivity is very important parameter when you are designing the system or analyzing the control system. Now there are, we can define the sensitivity. Let us say for in general the sensitivity we write it as STK. And how do we define STK? And it is defined as the percentage of change in parameter T due to the percentage of change in parameter K. Let us say T is my closed loop transfer function and K is one of parameter in the particular transfer function. What is the sensitivity? The sensitivity due to this K on T is, so what will be the change in parameters T due to the change in parameter K? Then we can define mathematically STK as delta T by T over delta K by K, or we can write as STK as delta T by delta K into K by T. The K can be anything. Now here I am taking two things. The one is my open loop forward path transfer function g, and other one is a feedback path transfer function h, which means first I will take stg, the second I will take sth. So let us look at what is stg. So stg indicates the change in the percentage change in t due to percentage change in g. So sensitivity with respect to the forward path transfer function g. Now let us take C of s by R of s. Initially we will take the closed loop transfer function and we will compare with the open loop later. So closed loop transfer function is C of s by s, R of s is equal to, I am taking as the t is g by 1 plus gh. So g we know it is a forward path transfer function, h is a feedback path transfer function. Now what is STG definition? We have delta t by delta g into g by t. So we will find what is delta d by delta g. So what is delta d by delta g? Change in t due to change in d, which is nothing but the differentiation. So I can find out dt by dg. So t we know g by 1 plus gh. With respect to g, if I differentiate, you will be getting as 1 divided by 1 plus gh whole square. Then when you substitute the formula STG, and we know this is delta t by delta g as 1 by 1 plus gh whole square into g is as it is, t is g by again 1 plus gh, g by 1 plus gh. So by resulting you will be getting STG as we have 1 by 1 plus gh. The sensitivity due to g is 1 by 1 plus gh for closed loop system. Then what about the open loop system? Means a non-feedback system. For non-feedback system, h is equal to 0, as simple as. So when you place this, when you remove the feedback, it becomes the non-feedback system. So for open loop system, h is 0, then STG is going to be 1. Then what I can say here, your STG is 1 for open loop and STG is 1 by 1 plus gh for closed loop. So closed loop sensitivity is reduced by 1 plus gh. So sensitivity is reduced, which means so it is less sensitive to the variations of parameters in forward path transfer function g. Next, I can also find out the sensitivity with respect to h, feedback path transfer function STH. Then, so what is h differentiation? We have dt by dh into h by t. So initially find out what is dt by dh, do the differentiation, we will be getting as dt by dh, and into we have h by t. When you substituting everything, you will be getting minus gh divided by 1 plus gh. This is for closed loop system or feedback system. Then what will be STH for open loop? Substitute h is equal to 0. When you substitute h is equal to 0, which results in 0. Means if in non-feedback system h is not there, then how can you define the sensitivity with respect to the h where h is not present? So that will be 0. Whereas for a closed loop, the feedback system has STH minus gh by 1 plus gh. So here also I can say when you compare STH and STG, STH is more we have effect on the system when compared to STG. Therefore my closed loop system is more sensitive to the parameter variations in the h when compared to parameter variation in the g. Therefore when you design the system, when you close the system, you must be very careful when you are choosing the sensor. If sensor is not robust, if sensor is very insensitive, sensitive to the parameter variation, that creates a lot of problem in the system. Then, so what is the effect of feedback on disturbance or a noise in the system? So let us look at a noise signal here. I have a block diagram like this. Let us consider the open loop, which is a non-feedback system. G1, G2, these two are the two blocks which I have, and here I have the noise signal which is entering to the system, which is N of s, and as usual we have R of s input and C of s output. Let us see what will be the effect of noise on the output. This is on feedback, which is open loop system. There are two inputs and one output. We will see in block diagrams. Transfer function basically defined for only single input, single output systems. Therefore, when you take the transfer function C of s by N of s, assume R of s is 0. So when you assume R of s is 0, I can say your C of s by N of s is nothing but simply G2. G2 is my gain for open loop system, where N is the noise or disturbance in the system. Now you close the loop, which means use the feedback. So when you use the feedback, assume a negative feedback, that to be your feedback gain is 1. Now look at the block diagram here. This is the input, which is R of S, and this is N of S, and I have summing point, two summing points are here. This is the actual system G2, and there is one more also G1. And you find out what is the effect of noise on the output of the system, which means C of S by N of S I need to find. And as we know, we need to assume R of S is equal to 0. When you assume R of S 0, there is a summing point, and I can remove the summing point in fact, but the signal which is coming is a negative. So remove the summing point, place a block with is -1, then what will be the feedback? The feedback which is a G1 and forward path is G2, then you can find out the transfer function, C of S by N of S as G2 by 1 plus GH. Now when you compare this a counterpart, which is my non-feedback system, where your C of S by N of S is only G2, in this case G2 by 1 plus G1H. So G2 G1H. So what does it mean? The disturbance, the effect of disturbance on the system is reduced by factor 1 plus GH. So that is the effect of feedback on whenever you have the disturbance in the, this is called the external disturbance, whereas sensitivity with respect to the parameter variations are internal disturbance, right. Next we will see what is a regenerative feedback. So what do you mean by regenerative feedback? Which is nothing but the positive feedback in the system. Let us look at the block diagram. This is G, this is H. Now I am taking the feedback positive. So we know that whenever you have positive feedback, my closed loop transfer function results in G by 1 minus GH. G by 1 minus GH. If you closely look at the denominator, we have 1 minus GH. If at all, if we choose H gain such that which is equal to 1 by G, there is always possibility. If at all, if you choose wrongly like H is equal to 1 by G, then what will be the C of S, H of S? It is going to be infinity, which is undesirable to me. So it is always better to avoid the positive feedback in the system. But sometimes in complex systems where there are many loops, and in internal loop, if you want to raise the gain, if you want to improve the gain locally, we may use a positive feedback. And the outer loop is always should be the negative feedback. You know what we use, why we use the negative feedback. So we use the negative feedback not to improve the stability or not to improve any other thing. The negative feedback is required in control system only to obtain the error. If we know the deviation between the desired value, actual value, then only I can design my controller and I can have the desired specification. The negative feedback is in control system only to get the deviation between the desired input, the desired response, and as well as the actual response.